Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of the Pythagorean Theorem, specifically how we can model it and describe it, and we will do it in 5 minutes or less. So there's something very interesting about right triangles. Now, it doesn't work for all types of triangles. It has to be a right triangle, so I'm going to make a right triangle there. And what was noticed thousands and thousands and thousands of years ago is that there is a relationship between the three sides of a right triangle. So we've got our right triangle right here, and so I'm going to put a little square there to kind of represent that right angle. And so we've got two smaller sides, and these are called the legs. And then we've always got a larger side. The larger side is always directly across from our right angle. And it actually has a very special name right there. And it's called the hypotenuse. What we found is that there's a strange relationship between the legs and the hypotenuse. Now, let's see what happens if I were to extend these sides into squares. What does that mean? Well, this bottom side right here is got, you can see it's got 3 squares across. So I'm just going to actually turn it into an actual square. So it's got a unit length of 3, and I'm just going to make it a 3 by 3 square. So we have now a total of 9 squares coming off the side of this triangle here. And so this other leg has got a length of 4, so I'm going to make a 4 by 4 square. And so this has got an area of 16. Now here is the cool thing, is if you take the area of both of those legs, add them together, it always equals the area of the square you can make off the hypotenuse. Now, this hypotenuse is a little bit harder because you can't necessarily see what the distance is here, simply because it's diagonal. But if you were to extend it up, and if you were to kind of pull it up right here, it would go to right there. So it actually, I know it actually has a distance of 5. So let's see if we can figure out what the area on the inside is. And we have to estimate a little bit, but let's go ahead and count our large full squares. Right, we've got 1, 2, 3, 4, 5. That's basically 6 right there. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this already in full squares makes up this 16 right here. So now we've got to kind of put two triangles together to make whole squares here. So let's see, I've got an extra one right there, so that's going to be 17. These two together make 18. These two together make 19. I've got that little corner right there to help that make 20, right? And we've got a little 21 right there, 22. I'm going to come back up here. We've got 23, 24, and then 25. So if you see that we've got 25 right here, we see that the square off this leg and the square off this leg added together make the square off this leg. And so the way we write that is, if we were to make a right triangle and if we were to label them, we could say this could be side A, this could be side C, B, and that hypotenuse is always going to be side C. Well, we actually write the Pythagorean theorem as this: A squared, that means you make a square off its side, plus B squared always equals C squared. And so even if we didn't have a particular model here, we could use that to solve, right? So if we had a triangle and we're missing some lengths, and we said, well, this is 25 and this is 36. Well, we could say, well, 25 squared plus 36 squared equals this C squared, and we can use that to solve for that missing side length of C. And that's the Pythagorean theorem.